Okay, this is the video on introduction to combinations, and so there's actually going to be a lot in this video, but we're going to be painting this picture of what a combination is. And so this is a really kind of neat idea. It's just from Harry Potter, and so there's this potion called the Polyjuice Potion, and so it's just this idea that you've got these ingredients that are very carefully selected. And so the question becomes, we really don't know, does it matter the order that the ingredients go in? And so really this is a question that's kind of interesting to look at because we have to talk about when order matters versus not. And here's like an ambiguous case where you can say order could matter, it could not. We really don't know much about the idea of like a potion. Uh, this is just a draw from Lotto 649. You can watch a video, but this is just kind of to picture um, how Lotto 649 actually works. It's nice to get like a visual of it. So to warm up, like we just look at the idea of like Canadian lottery with 49 numbers, and you have to select 6 of them without replacement. And the question is, does order matter? And so if you calculated the number of ways that if it did matter, that would be like a permutation idea, like 49p6, so 49, 48, 47, 46 all multiplied. Um, you could think about if that number would be bigger or smaller if order didn't matter, and like what would be the probability, like 1 out of that. Is that ever even possible? So that kind of gives you an idea of whether or not order matters or not if you actually calculate that 49p6. The big idea doesn't change. It's just the idea of making decisions, better informing our decisions with probability. So we are learning the difference between permutations and combinations. And so we're going to calculate, we're going to differentiate and explain the difference, and then communicate the connection. And that's actually going to be one of our big ideas, is just that connection between permutations and combinations. So versus, these are just definitions. So permutation is a way to arrange our objects from n, so from a bigger set. And it kind of uses the slot method. You're trying to figure out how many ways can go in each slot, and it always assumes that order matters. So it matters how many numbers go in each slot. A combination is similar to that, but it's not arranging, it's like choosing a group of our objects from set n. So these could be the same number. It's really similar, but the main difference is that order doesn't matter. An example, this is just kind of not really a question, it's just like point by point. If you had 6 people, there would be 6 factorial ways of arranging them side by side. So 6 times 5 times 4, 6 people in the first times 5 people in the second, all the way down to 1. That's 720 ways of arranging them. There is only one way of taking these 6 people, so imagine those 6 people are in front of you, and putting them in a group. So if you had to group all 6 of them, you just take all 6, and it's just a group of 6. So that one group of people, that one combination, what we call it, can be arranged in 720 ways. So if you took that one group of 6, you could arrange them in 720 ways. The permutation 6p6 is where we have 6 people in arranging all 6. That's 720. The combination is 6c6 and is read 6 choose 6, where we have all 6 people and are putting all 6 in a group. 6 choose 6. The one combination can be ordered 720 ways. So this is just kind of start to paint the picture of what a combination is. If you had these people, and so you can see like the letters of their name, in how many ways can you fill the positions of president, vice president, and treasurer? How many ways can you form a committee of 3? And so what I encourage you to do is like pause it and write out them all. You've got, we kind of know how many ways to do the first one. It's like 5 times 4 times 3. So that's 60 different ways. To form a committee of 3, where like ABC is the same as BAC, and just trying to get the unique letters and being systematic about it, if you write them all out, you'll actually see there's 10 ways. So to calculate the number of combinations, it's helpful to understand. If we arrange each group of 3, so if we got the groups, and you've kind of written all 10 groups out, we get the permutation, because you could take each group and arrange it to get the permutation. There are 3 ways of arranging each group. So if you can think about it, like there's 6 ways of rewriting ABC. Um, and so that's 3 times 2 times 1. If we multiply the number of groups of 3, so the number of combinations, by 3 factorial, we get the permutation. So you can imagine like all 10 of these groups and then 6 kind of like arrangements for each group. Then we're just taking like 10 and multiplying by 6. And that's actually going to give us the 60. We know the permutation is 60. It's 5 times 4 times 3. That was like what we did in permutations and slot method. To get the combination, we could take this kind of formula here and say 5 choose 3 times 3 factorial equals 5p3. So you just say that 5c3 is 5p3, which is 60, divided by 3 factorial. And that's the formula for a combination. It's just that you've got to kind of understand this link of like the 6 times bigger. And if you know that there's less combinations and permutations, you can kind of like make that link between 6 times bigger. Consider another example, and this is where we get into like the potion or the soup. If you had 13 ingredients for a soup, how many ways could you place the three of the ingredients in the soup in order? So let's say like the order matters. And then how many ways are there to choose 3 ingredients if order doesn't matter? And so that you can kind of think about like how that would work. And then if you pause it, you can kind of think about your answers there. And so the answers would be like the permutation for number 1, so 13p3. So 1,716 possible orders, 13 times 12 times 11. The combination would be like the 1716 divided by the number of ways to arrange each group. So if you had like the number of groups and then you like took them and arranged them, you could multiply the permutation by 6 to get the combination, or sorry, the combination by 6 to get the permutation, or divide the permutation by 6 to get the combination. Here's a video that kind of helps like explain that, so you can watch that on your own time. The combination formula in general is like NCR, which is NPR over R factorial. And if you sub in the factorial part of NPR, like you actually get this part here, n factorial over n minus r factorial, is the permutation, and then divided by another r factorial is the combination. So you can see it's smaller because it's got that extra r factorial on the bottom. Another example with cases, so if you're like kind of making a soup with 10 different ingredients, and we got 4, 5, or 6, you can actually use combinations to like just get used to it and say, so how many, case 1 would be 4 ingredients, so there's 10 choose 4 ways, which is 210. Case 5 is 10 choose 5, which is 252. And case 6 is 10C3, which is 210 again. There is an interesting pattern that we're going to talk about in the next video about why these are both 210 and that kind of thing. But if you add these up, you get 672 soups. One more example, when drawing 5 cards from a standard deck of 52 cards was probability drawing 3 5s. You can see the 3 5s here. So you've got probability, so probability is still n of s and n of a, and so we're going to figure out n of a and then n of s. And so n of a, the question is like, all right, out of how many 5s, how many are you going to draw? And does order matter? And so if we kind of realize order doesn't matter, we put the cards in any order we want. We can say that there's 4 5s and we're going to choose 3 of them because we want 3. And then out of the remaining cards, so we kind of take out all of the 5s. Out of the remaining cards of 48, we're going to choose 2 more. This is the part that people usually miss. As my cursor gets bigger, this is the part that people usually miss, but it's really essential because there's not just 4 choose 3 ways of drawing 3 5s. There's 4 choose 3 times 48 choose 2, which is a lot, actually a lot more ways to draw 3 5s. Because like this king and 9, they could be any 2 numbers here. And then n of s with 52 cards and drawing 5, you just have the total, which is 52 choose 5. And then you can divide those to get the probability. One more example, so with the lottery, and this is actually from Lotto 649 website. And it's here just to kind of check out we're going to do 2 of these probabilities and prove that they're the same. Find the probability of winning the jackpot. So N of S is actually 49 choose 6. Order doesn't matter with the lottery. So it's just 49 choose 6. Out of the 49 total, you've got choose 6 to pick. Winning the jackpot is really, there's only one way to do it, and it's 1 out of the 13 million. But we can also calculate that by saying 6 choose 6. Out of all the 6 winning numbers, you're going to choose all 6 of them. And so that's 1 out of 13 million, and you can see that's like the same number here. That's where they get it. Matching 4 of the 6 is kind of like the 5s, and we're kind of making 2 groups. And so N of S is still 49 choose 6, but we're gonna group the lottery numbers into like winners and losers. And so out of the 6 winners, we're only gonna choose 4 of them. But then here, kind of like the 5s, out of the 43 remaining numbers, we're going to choose 2 of them. And that's 13,545 ways. And the total is 13,983,000. And if you divide those, you get about 0.1%, which is the same as this 1 in 1033. If you reduce this fraction, you would get the same thing. So about 0.1% or 0.0969% chance of matching 4 of the 6. And you can watch the next video for the rest of it.